Friends, welcome to my channel. Dhanesh here. A priori is an algorithm for frequent item set mining and association rule learning over relational databases. Item set mining is finding frequent patterns, associations, correlations, or causal structures among sets of items or objects in transaction databases, relational databases, and other information repositories. Association rule learning is a rule based machine learning method for discovering interesting relations between variables in large databases. For example, peanut butter and jelly are frequently purchased together because a lot of people like to make peanut butter jelly sandwiches. Association rule mining is a technique to identify underlying relation between different items. Take an example of a supermarket. Take an example of a supermarket where customers can buy variety of items. Usually there is a pattern in what the customer buy. For instance, mother with babies buy baby products such as milk and diapers. Damsels may buy makeup items, whereas bachelors may buy beers and chips, etc. In short, transactions involve a pattern. More profit can be generated if the relationship between the items purchased in different transactions can be identified. For instance, if item A and B are bought together more frequently, then several steps can be taken to increase the profit. For example, A and B can be placed together so that when a customer buys one of the product, he doesn't have to go far away to buy the other product. People who buy one of the products can be targeted through an advertisement campaign to buy the other. Collective discounts can be offered on these products if the customer buys both of them. Both A and B can be packaged together. The process of identifying an association between products is called association rule mining. A priori algorithm for association rule mining. Different statistical algorithms have been developed to implement association rule mining, and a priori is one such algorithm. In this video, we will study the theory behind the a priori algorithm and will later implement a priori algorithm in Python. Theory of a priori algorithm. There are three major components of a priori algorithm: support, confidence, lift. I will explain these three concepts with the help of an example. Suppose we have a record of 1000 customer transactions and we want to find the support, confidence and lift for two items, example burgers and ketchup. One of example burgers and ketchup. Out of 1000 transactions, 100 contains ketchup while 150 contains a burger. Out of 150 transactions where a burger is purchased, 50 transactions contains ketchup as well. Using this data, we want to find the support, confidence and lift. Support. Support refers to the default popularity of an item and can be calculated by finding number of transactions containing a particular item divided by total number of transactions. Suppose we want to find out support for item B. This can be calculated as support can be calculated using the formula support B is equal to transactions containing B divided by total transactions. For instance, if out of 1,000 transactions, 100 transactions contains ketchup, then the support for item ketchup can be calculated as support ketchup is equal to transactions containing ketchup divided by total transactions. Support ketchup is equal to 100 by 1,000, that is 10%. Confidence refers to the likelihood that an item B is also bought if item A is bought. It can be calculated by finding the number of transactions where A and B are bought together, divided by total number of transactions where A is bought. Mathematically, it can be represented as confidence A to B is equal to transactions containing both A and B divided by transactions containing A. Coming back to our problem, we had 50 transactions where burger and ketchup were bought together, while in 150 transactions, burgers are bought. Then we can find likelihood of buying ketchup when a burger is bought can be represented as confidence of burger ketchup can be mathematically written as confidence burger to ketchup is equal to transactions containing both burger and ketchup divided by transactions containing A. Confidence burger to ketchup is equal to 50 by 150, that is equal to 33.3%. You may notice that this is similar to what you would see in naive Bayes algorithm. We have a video for naive Bayes. However, the two algorithms are meant for different types of problems. Lift. Lift A to B refers to the increase in the ratio of sales of B when A is sold. Lift A to B can be calculated by dividing confidence A to B divided by support B. Mathematically, it can be represented as lift A to B is equal to confidence A to B divided by support B. Coming back to our burger ketchup problem, the lift burger to ketchup can be calculated as lift burger to ketchup is equal to confidence burger to ketchup divided by support ketchup. Lift burger to ketchup is equal to 33.3 divided by 10, that is equal to 3.33. Lift basically tells us the likelihood of buying a burger and ketchup together, that is 3.33 times more than the likelihood of just buying the ketchup. A lift of 1 means there is no association between products A and B. Lift of greater than 1 means product A and B are more likely to be bought together. Finally, lift of less than 1 refers to the case where two products are unlikely to be bought together. Steps involved in a priori algorithm. For large sets of data, uh, there can be hundreds of items in hundreds of thousands transactions. The a priori algorithm tries to extract rules for each possible combination of items. For instance, lift can be calculated for item 1 and item 2, item 1 and item 3, item 1 and item 4, and then item 2 and item 3, item 2 and item 4, and then combination of items, example item 1 comma item 2 and item 3, similarly item 1 comma item 2 and item 4, and so on. As you can see from the above example, this process can be extremely slow due to the number of combinations. To speed up the process, we need to perform the following steps. Set a minimum value for support and confidence. This means that we are only interested in finding rules for the items that we have certain default existence, example support, and have a minimum value for co-occurrence with other items, example confidence. Extract all the subsets having higher value of support than minimum threshold. Select all the rules from these subsets with confidence value higher than a minimum threshold. Order the rules by descending order of list.
Thanks for watching. Please like, share, and subscribe. Thanks a lot.